Mary.
Hey Ralph, you want to shoot some hoops?
Sure. Thank you.
Mary, you should be outside studying, not playing basketball.
But Dad!
No buts about it.
Well, actually, sir, basketball's all math and physics.
Is your name Mary?
Come on Dad, we'll go show you.
Alright, you got me here. Now teach me.
So, let's start with the measurements. Your typical high school basketball court is 84 feet long and 50 feet wide. Since the area of a rectangle is length times width, all we have to do is 84 feet times 50 feet to get 4,200 feet squared.
So the painted area of the court is about 19 feet. So if you subtract the length of how far the hoop comes out, which is about 4 feet, the painted area will be 15 feet in length and 12 feet wide. Now if you're aiming to shoot a 3-point shot, it's going to be 19 feet 9 inches from the top of the key and the corner. But if you want to get really fancy and shoot from half court, it's going to be approximately 40 feet in length.
Half court shot. I can do one of those.
So now let's talk about the measurements of a rim. A basketball rim has a diameter of 18 inches, which means its radius is 9 inches. Since the rim is a circle, we can find its area by pi r squared. Since we know the radius is 9 inches, all we have to do is plug in. So for r we put in 9. And we end up with our area of 81 pi, or approximately 254.47 inches squared.
With an area that big, you'd think you'd be able to make more shots.
Okay, Dad, let's get back to math. Okay, so the circumference is equal to 2 pi r. So all you have to do is plug in 9 inches for the radius. So the circumference is equal to 18 pi, which is approximately 56.55 inches. So now let's talk about the basketball. The circumference of my basketball is 29.5 inches. Now, since we know the circumference, we could use this to find the radius. Circumference is equal to 2 pi r, and we know the circumference is 29.5 inches. So we set this equal to 2 pi r. Now, to get r by itself, we take 29.5 inches and divide it by 2 pi equals r, which is approximately 4.7 inches.
So now that we have the radius, we can use it to find the volume. So the volume of a sphere is 4/3 pi r cubed. So all we have to do is plug in the radius. And eventually, we're going to get 434.89 inches cubed.
This reminds me of what I used to do in my college days for fun. Let's see if I can teach you guys anything.
First is you always have to draw a picture. This is me with a basketball. And the court, the hoop, And I'm going to shoot the basketball at a 45-degree arc. It's going to travel into the hoop. Now we know that a half-court shot is 40 feet, and the height of the basketball hoop is 10 feet, and I, with a basketball and jumping, am about 7 feet. So now we got to convert these units. So now I have to convert the units to metric. I know that there are 3.28 feet for every meter. So if we got 10 divided by 3.28, it's going to give us something around 3 meters. And we got 40 feet divided by 3.28. That's going to give us somewhere around 12 meters. So now we got our meters. Oh, wait, we got 10 and 7. That's going to be about 1 meter. There we go. Now let's set up an equation. Alright, so the equation for projectile motion is the Galilean equation, which tells us the change in distance, which I'm going to call y because we're working in a vertical component, is equal to the initial velocity times time plus 1/2 the acceleration, which is gravity, times time squared. So, in this equation, we have the difference in height is going to be 3 meters minus 2 meters, which is 1. And that's going to equal the initial velocity that we're solving for. I'm going to say the hang time is 2 seconds plus 1/2. The acceleration is 9.8, and that's a negative because it's going downwards, times 2 squared again. So if we just get rid of some of our things here and do some math, we got 2vi plus 19.6. Now, that's a negative. So let's bring it back over. We got 20.6 is equal to 2vi divided by 2, and vi is equal to 10.3. But that's not enough, because this is just the vertical component. So, in order to get the actual velocity coming out at 45 degree, we need to use our sine technique. So if we draw our triangle with a 45-degree angle, we got x right here, that's what we're trying to find, and then we got 10.3 right here. So if we have the sine of 45, because we have opposite over hypotenuse, sine of 45 is equal to 10.3 over x. So now we just rotate the sine 45 in the x. We got x is equal to 10.3 over sine of 45. X is going to equal 14.57. And that's meters per second because it's velocity. Alright, now we're going to try to find the momentum of the basketball. But in order to get the momentum, we need to find the mass. And we already know that the basketball has a mass of 22 ounces. But ounces don't help me at all, so I'm going to convert this to kilograms. But I know that there's 35.274 ounces in a kilogram. So let's convert 22 ounces to kilograms. We got 22 divided by 35.274 is equal to 0.62 kilograms. And that is the mass of the basketball. So now that we have the mass of the basketball, let's get the momentum. So momentum, as described by P, is equal to the mass times the velocity. We already know mass and velocity, so this is going to be easy. P is equal to 0.62 times 14.57. Continue the calculations, and this is going to be 9.0374. And this is momentum, so it's going to be kilograms meter per second.
All right, old man. Let's see what you can do on the court.